Hello everyone, this is Pavithra, Assistant Professor, Department of ECE. Today we gathered here to take a video of case study that is a smart home weather monitoring system. These students are from second years. So I am handling the paper of digital electronics. The weather monitoring system with the help of this digital electronics. So we came up with this topic of weather monitoring system. So we know already what is a smart home weather monitoring system. So we don't want to have a switches and all. We don't want to be present in the home. We can automatically access the switch point in anywhere in some other places, right? That is a weather monitoring system. Why we are came for weather monitoring is nothing, because nowadays we are having a flood and over temperatures. These are all the problems we are facing. So we are came up with the weather monitoring system. So here commonly we are using the microcontroller, sensors, and basically we are using the ICs and the logic gates. That is a half adders and all we are using. My team is going to explain one by one about what is the process, and they are going to explain the real-time example.
Hello everyone, I'm Vishal. I'm currently pursuing CSC in SNS college. I'm going to explain the simple and basic introduction of a weather monitoring system. It's nothing but in modern cities like Chennai, for example, like Chennai, Bangalore. Both husband and wife are going to work. Then who will take care of the children? If a children in the home alone, he cannot access the AC heater. If in Chennai and Bangalore already overheat, then the baby cannot survive in the dust temperature. So if a simple weather monitoring system is connected in the house full of efficiency, it is an efficient to all the houses in Chennai, because how it can be helped if it is over rainy, then you don't want to on any switches and you don't want to any control in the room. It automatically have a room heater to on and keep the room in a correct temperature to survive. And if there is an over heat flow in outside and the heat flow in inside, then nobody can sit inside. So it automatically given a sensor and radius reduction to on the AC and keep the correct temperature around us. It can be more quick and energy efficient, because if unnecessarily don't want to AC want to play in our house, our room heater want to run in our house, so it is very efficiency, and it can be what we can say, it make quick decisions and efficient decisions in the correct timing with using for example logic gate with the using of a half adder, and half adder can be fully explained by Satish.
Good morning everyone, I am Shakti. I am currently pursuing B. Computer Science and Engineering at SNS College. And today I am going to talk about off order is used in weather monitoring. Off order is nothing but is a combinational circuit. It does not depend on the past input, and by off order is nothing but currently giving a 2 input, it produces the 2 output. It is called as off order. Why we are using off order in weather monitoring is we use 2 sensors in the smart home, which is one outside of the home and inside of the home. So we use off order where it gives 2 output, the sum and carry. For sum we have XOR gate, and the carry we have AND gate. Sum indicates that exactly one true condition, and carry indicates that exactly true condition. The full off order will be explained by Kamala.
Before that, let me see an example scenario. Let's take a home situated in a suburban neighborhood. It will be equipped a weather monitoring system to make it continuously make it improve whether the surrounding is safety, comfort, and it is an energy efficiency. To make this smartphone weather monitoring, let's take 2 binary sensors. One is temperature sensor and another one is rain sensor. In both the sensors, let's take two outputs. First, temperature sensor. Temperature sensor is normally detecting the temperatures. First, the outputs are the zeros and ones. If the temperature is normal, it does not need any cooling or heating, right? Then the output will be 0. If the temperature exists, its threshold, the home should be having heat, so the output will be 1. It will be depending upon it will be connected to the air conditioners and fans, exhaustion fans. It depends upon this, and it is directly connected to that, the temperature sensors. And then rain sensor. Rain sensor is kept outside. It is used to predict the outside temperature, outside environment, how it is. So it also has two outputs. One is 0, one is 1. And if no rainfall is detected, the output will be 0. And if rainfall is detected, the output will be 1. It also connected to it is not connected like fans and air conditioner, but it will be predicting from the sky predictions and automatic windows. Depending upon that, it is connected and it will be prevented. By using this temperature sensor and rain sensor, we will be processing in the off adder, and it produces, as she said, it will be giving two outputs like sum and carry. It will be more clear by explaining with truth table. Truth table will be explained by Teshna.
Hi guys, I'm Teshna from second year CSE department, and I'm going to explain about the truth table. So let's consider a table. The first column will be temperature, and the second will be about a rainfall, and there will be sum and carry options, and the last will be how the smart work applications, smart home applications in the action plan will be executed according to our project. So the first case, let's take there is no rainfall and the temperature is normal. So in this case, the carry and sum will be 0. The action plan, there will be no action plan because there is no temperature. The temperature will be normal and there is no rainfall. Then let's take the second condition. In second condition, the temperature is normal and there is no rainfall. There is rainfall. In that case, the sum will be 1 and the carry will be 0. So in this case, the rainfall is there. So the smart home, it will automatically acknowledge that one action plan should be done. So the windows will automatically close off to stop the rain, to prevent the rain waters to come inside the house. When we take about the third case, in the third case, the temperature is hot and there is no rainfall. In this case, the temperature is very high. So according to this, the sum will be 1 and the carry will be 0. So the smart home applications, it will automatically turn off the ACs all around the house. So this prevents the normal temperature to accommodate the normal temperature in spite of the high and hot weather temperature. In the fourth case, let's take the temperature is also high and the rainfall is also occurring. So both the rainfall and temperature act simultaneously. So in this case, two action plans should be done. So the sum will be 0 and the carry will be 1. So in this case, the smart home actually does two works. The first is it automatically closes the windows, and the second, it turns on the AC. So in this case, it prevents two things. The water will not come inside the house, and the temperature, it acts cool. This way, we can also there is more about the ways to explain that both the smart houses, the temperature also should be normal, and the rainfall or whatsoever the action plans or any disasters come, the smart home works properly according to wherever the places people can access it wisely. The next will be explained by Tamil Bhati.
Hello everyone, myself Tamil Bhati. I am currently pursuing my second year BA Computer Science and Engineering at SNS College of Technology. Now I am going to explain why we use off-adder in this system. So there are 4 reasons. Let me explain. First one is binary outputs. So weather sensor, we use 2 sensors, like one is inside and other one is outside. It gives 2 outputs, zeros and ones. Zeros mean non-trigger and 1 mean triggered. So we use off-adders. So second one is it gives real-time decision making rather than go for complex microcontrollers. And third one is saves power efficiency. It works on automatically, so